Today we're going to look at adding equations to solve systems of equations. We often call this elimination by addition. The first step in this process is to take the two equations that you're given and make sure both are in standard form. Take a look at the following two linear equations. Please pause the video and put them in standard form. When you're done, press play to see the solution. Here's the two linear equations written in standard form. Please pause the video and copy this into your notes. The second thing we need to do is make sure we can use this method. To determine if we can use this method, we have to look first to see if the value of a and b are the same number in both equations for either a or b. Once we see that, we can move on. Well, if we look at the a term, the value next to the x variable, they're both 3 in both equations. The second thing we need to determine is if the values are of opposite sign. We see in the blue equation we have a positive 3, in the green equation we have a negative 3. Since both these conditions are true, we can move on with this method. The next thing we need to do is to align the two equations on top of each other as we have over here on the right, then add the like terms, which will result in one of the variables, x in this case, being multiplied by 0, thus being eliminated in the new equation. For example, (3 plus negative 3 is 0. 2y plus 5y is 7y. 10 plus 15 is 25. 0 times x is 0. 0 plus 7y is just 7y. The next step is to solve the remaining equation, the new equation, for the variable that's remaining, which in this case is y. To do this, we're going to divide both sides by 7 and get y is equal to 25 over 7. Please pause the video and copy this into your notes. The next thing we're going to do is substitute back into the original equations to find the remaining value. We need to make sure we go back to the original equations. So choose one of the two, the blue one or the green one. I'm going to choose the blue one, just because 2 is smaller than 5, and it's going to be easier to multiply. So we substitute the 25/7 in for the y value, then solve the equation to find x. Please pause the video and solve this equation for x. Once you've found the answer, please hit play. If you used decimal, you would have gotten approximately 0.95. Please pause the video and copy this into your notes. The two numbers that we now have for x and y make up the intersection point of the two lines, which is at 20 over 21, comma, 25/7, or 0.95, comma 3.57 if you chose to do this in decimal. Please pause the video and make sure you have this full list of process into your notes. Here's a new problem for you. Please pause the video and use elimination by addition, if you can, to find the intersection point of these two lines. Make sure you pause the video. So the first thing I did is rewrote the second equation in standard form. The first equation was already in standard form, so I didn't have to worry about that. Please copy this into your notes. So now that we've taken care of the first step, let's look at the second step where we make sure we can use the method. It turns out that the x value both have the value of 6. They're also both opposite signs, so it looks like elimination by addition will work here. When we solve the system by adding the two equations, we get that y is 29 over 12, or approximately 2.4. Please pause the video and copy this part into your notes before we move on. When we plug back in and solve for x, we get that x is negative 49 over 72, which is approximately negative 0.68. Therefore, the intersection point of our two lines is negative 49 over 72, comma 29 over 12, or in decimal, negative 0.68, comma positive 2.4. Please pause the video and copy this into your notes.